Hi everyone. So today we'll be exploring about categorical data, the unit one from the Khan Academy portion for the AP college statistics. So let's get started with the first unit. Okay, now let's see. Here they're just saying here Madison recorded. So it's just basically individuals, variables, and categorical and quantitative data. Madison recording some weather conditions for some major cities on the same day. And just the same day where he was recording the weather conditions for some major cities. And here is some data he has collected. She has collected. So basically, it's Detroit, San Francisco, New York. And then, yeah, this is the temperature. So high temps is given here 26, 20, 20. And this kind of precipitation, rain. Did it rain that time? Or was it like none? Wasn't it raining? Or was it raining? Then there's like average wind speed, whereas wind speed and whether there was a severe alert. So basically, now if we see here, now they're just asking what are the individuals. Now, individuals always means, remember, individuals generally means the first column. That's not the most, I would say, mathematical definition of it, but generally it's the first column. Individuals generally means is when they're saying, I'm recording this for some people. Let's say I'm recording this, all of their gender, age, race, and income for some individuals. So those individuals are considered like for some people, let's say John, Jack, Jilly, or whatever. Those people are considered my individuals in the data set. What am I doing all of this for? What is the main purpose? For whom am I doing all this? I'm doing for those people. So they are my, I would say, individuals in mathematics for the data set. For my data set, those are the individuals I'm doing this for. So therefore, I'm measuring the temperature, the precipitation, the wind speed, and the severe alert for whom? For the cities. So therefore, the city name or the cities are considered my individuals. So based on that, yes, we will pick cities. That should be the correct option. We'll say our individuals in the data set are going to be cities. Now, they're saying this data set contains, okay, blah, blah, blah. Okay, now they're given quantitative and categorical, right? So yeah, how many variables are there? Now, if we see here, how many variables do you think are there? So variables basically means the thing we are using to measure these specifics. So basically the quantity, like each of those, I would say aspect or each of those, type of thing we are measuring, like we're measuring the temperature. That's one variable. Okay. This is defined as something like we are measuring some specific data. Just check here. Yeah, it's basically a characteristic. Okay, it's just a characteristic or a number that can be measured for some data units. That can be measured for individuals. So basically, if you measure their gender, if you measure that is a variable. Okay, male or female, or the income if you're measuring for some individuals. That's a characteristic of them. How much they earn? Are they lower income, middle income, upper income, whatever? So here we're just measuring now quantitative and qualitative. So quantitative data is numeric. Basically something like, that's more into numbers. More into numbers means it's quantitative. More of numerals, like, height, weight, test scores, my income or whatever. For qualitative, it's generally attributes or groups. So like gender, gender can't be one or two. It's just male or female. Or race, gender, race, brand, hair color. Kind of precipitation is also something, where you have rain or not. We don't have one or two, like numbers. So quantitative means here we have numbers and we have numbers in two and yes, one. So yeah, two are considered quantitative. I'll just say it's QA or short. And then kind of precipitation is where it falls into more of a, it's type this one or this one. So it's categorical. Categorical or qualitative. I'll just say QA. Categorical. That's categorical data. Based on that, how many quantitative and qualitative categorical data we see? Two are quantitative, two are numerical values that are falling into the range of, that are involving numbers, that's measuring some of numbers. Qualitative is just measuring characteristics, it's just measuring kind of, attributes or groups. Based on that, we see here we have two categorical variables, which would match up here, and we see, yeah, four variables. So yeah, three we don't have, so C and D just rule out. We have four variables. We have four variables with two which are categorical. Excuse me. Let's check that. There we go. Perfect. Let me read all of this stuff and let's just go back to the problem. So yeah, Mr. Gregory sold several cars this week. So he's just selling some cars, okay, this week. Now here also same thing. What is he selling? He's selling cars. Now remember, guys. What is all this? Retail price. These are the four variables. Okay, just four variables. Now, how do we say these are the four variables? Why not cars sold is a variable? Because all of this data is about the cars he's selling. Okay, this is all about the cars he is selling. So basically, cars is the individual, which is these variables are the specific characteristics of that individual, Okay. It's basically like variable is any characteristic number or quantity that can be measured or counted, right? So variables is a characteristic of the number of the thing of the individual. In quantitative, as you know, it's just measurable quantities. Qualitative means it's just describing attributes or groups. So it's just describing attributes. Attributes means qualitative, okay? And quantities, like numerical, is just quantitative. So remember, categorical means into categories. Numerical means into numerals, values, into numbers, I mean to say. So here, if you see here, we just have four variables we can include because it's just describing those retail price. So retail price for a car, miles per gallon for a car, seats for a car, navigation for a car. Everything is describing all the way to the car. So this guy is also describing car. This one is also describing car. This one is also describing car. This one is also describing the same car. So therefore, the individuals in this data set should be cars. That's what we can conclude. They should be cars. So therefore, we're going to just pick that. And yeah, data set contains how many variables as, yeah, now this one contains actually we just saw, right? Four variables. Now, how many are quantitative and qualitative? Let's make another assumption. Let's just try to, kind of play it around, just figure out, which ones are quantitative versus which ones are qualitative. So basically, if you guys see here, where do you see numbers? This one is number, this one is number, this one is number. That means they are quantitative. Which one is not number? Yes, no is attribute. Remember, it's not a number. It's not a one, two, three, four. It's just describing something where it's just describing, an attribute. This is something like, it's where it's grouped. So basically, we can just say yes, no is considered a qualitative variable or a categorical. It's just a category. Like it's just a category, either yes, either no. There's two options. In numbers, we have unlimited actually, in theory, right? Because numbers can go till unlimited. In categorical, we have just categories. So we just have a limited number. That's how you guys can understand. Categorical means limited, and numerical means it's kind of unlimited. In theory, at least. And then data set contains four. And we just see here one is qualitative, one is categorical. Navigation is categorical. Seats, miles per gallon, real price are all quantitative, all numerical. So therefore, we can conclude four variables, of which how many are quantitative? Three are quantitative. Yeah, and one is categorical. There we go. Okay. Now let's choose this one over here. So now here, if you see, let's try to notice. So Alex is taking inventory of styles, compression bandages forward. So just taking inventory of styles of compression bandages. Now they're just giving up Simpson data for his compression bandages. Now, what are compression bandages? I think, yeah, I think they're just kind of something where, yeah, it's just something like an elastic, I guess, bandage, where they just wrap around to kind of reduce swelling and apply some gentle pressure. Just for elevation of pain, they use it from injuries. So yeah, for minor sprains, strains, fractures, they just use this kind of bandages, compression bandages. And now what he's doing? He's doing, remember, he's taking inventory of styles of compression bandages for work. So what he's doing? He's doing everything for compression bandages. Okay, he's doing for what he's doing for is taking inventory of styles. Now styles of compression bandages. So he's doing everything for this. Now styles of compression bandages. Someone could be this style, that style, whatever different styles we could be having. By the way, how many styles do we have? Let me just check here. Styles, compression bandages. Yeah, we have, specialized, stretchable, rigid, different types we have. So that way we can say that styles is doing everything for the styles. So styles should be the individual. Styles of compression bedding. We see that option over here. He's doing the style ID with total yards and color, all four variables. Remember, color of the style, total length of the style, or style of compression bandages, width of the style of compression bandages, how long is it? And style ID also it has. Okay. So it's basically all these four things are pointing to the same thing. They're pointing to that same thing over there. Therefore, we can say it's going to be compression bandage styles as our individuals. Individuals, what are we doing everything for? What is the whole purpose? What is the sole purpose? What is the bigger picture we're doing all of this for? What is the main thing? Compression bandage styles. Yes, that is the one of the individual. I mean, four variables we have, and how many are quantitative, how many are qualitative? Let's figure that out. How many are numbers? This one is number, this one is number. Now 033. That means also actually a number, right? Yeah, that is also considered a number style ID, I think. If I'm not sure. Let me just check. I think it's ID. Let me just check. I think it should be categorical of difference. Oh yeah. See now here IDs actually we can just say is IDs should be considered an attribute of something. So IDs are considered qualitative or categorical. My bad. I think it should be considered categorical because what happens is IDs is basically we can't get the mean of IDs, right? We can just get the mean. We can actually count 1, 2, 3, 4, 5, 6, but we can't take 0, 0, 3, 0, 0, 4. We can add. You cannot do mathematical operations around them. That ways we can say style ID is not actually something of a more qualitative. I mean, so not something of a more quantitative. It would be something of a quantitative because they consist of digits that is unique labels, okay, to identify or classify the information. They cannot be measured or we can't average, we can't add IDs. They're like labels, they're not measurements. So mathematical value. So that ways we can say here now, see whether we can measure definitely 1, 2, 3, 4, 5. So you can get the mean, you can get the mean, median, mode, everything of this. Style ID, you can get the mean, median, mode. So yeah, this one is actually uh quantitative Q, and this is also quantitative Q. Which one is categorical? Let's figure that out. Now this one is actually categorical. Okay, color is of course categorical. Standard is also categorical. So two quantitative, two categorical, and four total variables we have over here. Let's check that out. It should be four or wait. How many variables should it be? Oh, categorical. Wait, what are the same here? Let's choose some variable. Three variables, three of which are categorical. Okay. Wait, style ID. Okay, yeah, style ID is okay, okay. I think I just got it messed up. Yes, this style ID is actually, recognizing each of the thing. So it can be considered a variable. It's actually considered more of an individual. Okay, that's defining its identity, something like a name of the specific style. So it's basically a thing. So yeah, that's not considered a variable with total yards and colors also considered, of which only now, if we see, guys, only one of them is categorical, right? This is actually style ID is referring to the individual itself. It's the individual identity of mine. So that's not a variable. Yeah, that's going to be an individual itself. So yeah, style ID is individual. So therefore, what you can say here is it is basically personal. Okay, it's just personal describing that same thing. Just a unique way of describing a specific style. So yeah, therefore we can just consider we have three variables, of which just one of them is categorical. So guys, I think I just messed up with that. Let's check that out. Yeah, let's just read through this, so that way we can just see. Yeah, individuals are the people or things described by a data set. Yes, individuals are the things that is styles have been described by this data set. Labels are characteristics of the individuals that we measure or observe. Categorical variables take on values that are labels or categories. Yeah, categorical variables means categories, quantitative means numerical, we know. The individuals described by this data set are styles of compression managing. Yes, that's describing the styles. And now, if you see here, the characteristic describes. So, yeah, style ID is just describing itself. So, it's this identity. So, yeah, that's not a variable. Only width, total length, and color are the variables. And there we see this color is categorical, right? Because width and total length are in numbers. Those ones are, like we measure that can be done mathematical operations around width. So yeah, one of them is categorical. So yeah, the answer is just going to be the individuals in this data set are compression and styles. The data set contains two variables, of which one is categorical. There we go. Awesome. Okay. Rachel gave a survey to her classmates to learn about the statistics. So she's taking a statistic survey. Now here's some data she collected. Now student names. So now student names basically identifying this. So look at like ID, it's my identification. So that's not a variable. It's not describing me, my gender or something. It's just basically me itself, right? It's just describing, it is just basically me itself. So Jacob, it's him itself. It's not a variable. It's just a person itself. Twenty is the person itself. Mora is the person itself. That way, they are the individuals. And if you see Rachel's teachers, Rachel's classmates or horoscopes, which one do you think it should be? Yeah, Rachel's classmates. Classmates are, yeah, they're coming to the classmates. So yeah, those classmates are the specific individuals whom they're trying to study about and trying to read the horoscope, birth month, age, and gender. They decide how many variables does it fit. We see gender, age, birth month, and read horoscope. These are the four variables of those specific, of the specific student. So yeah, for the specific student, now these are describing the attributes. Okay, gender is actually one way to identify itself, but it's a categorical thing because it's just grouping me into stuff that am I male or am I female. Or am I like neither? Whichever gender I belong to. Student name is, describing itself. Student name is describing the person itself. So yeah, therefore we don't consider that as a variable. That is considered more of an individual person. This is the person itself, whom these all things are describing. So yeah, data set contains what? Four variables, of which how many are quantitative? If you see here, male and yeah, birth month, read horoscope. See, read horoscope is also yes, no, category. Birth month is also category. It's not numbers. Only age is numbers. Gender is also category. So yes, one is quantitative, three categorical, and yeah, four variables of one is well, yeah, one is quantitative of four variables. Let's check that out. Okay, I think it's taking some time. Hmm. Okay, let me reload this to get this. Sorry guys, let me just take these in. There we go. Okay. Awesome. I think we got it correct. I don't know. I just froze that middle way. No worries. We can, I think we just go ahead with the next one. So basically, let's go back here and proficient. Yes, there we go. Okay, we are proficient at this one. Yeah. Now this one we did. Let's try. Actually, what you can do is, yes. Now let's maybe practice this some more if you want. Or I think we can just go move on the next one. I think it should be better. Let's move on next one. Read bar graphs. Yeah. Now let's read this bar graph. Now it's going to be interesting. So James counted the number of alligators in local bodies of water and graphed the results. So he's just counting how many alligators are there. Now, which bodies of water have the same number of alligators? Okay. Now, this one, what do you think, guys? Which bodies of water had the same number of alligators we can see is? Now, this one is basically graphing the different places. So, Reptile Creek is there. How many alligators does it have? Now, bar graph is something where you have all the locations on one end, all of them are here. Okay. You could actually even have the opposite, like, all the locations here, places here, no alligators on the left side bar. Either way, I guess fine. It's just like Reptile Creek, Danger River, Chomp Lake, and Bite Swamp. Those are the four ones. And then it's just graphing like Reptile Creek has nine. That's one. So yeah, basically just going till nine. So it's just basically nine alligators in Reptile Creek. Danger River is still 12. So it's just about 12 alligators. Chomp Lake is just about six alligators. And Bite Swamp is about 12 alligators. There we go. So yeah, that ways we can conclude which had the same number of alligators. Now, what do you think here? So this one had nine, this one had 12. Okay, because this matches here till 12. You guys see, this is still nine, this is nine, this is six, this is three. So yeah, that way this one, Trump Lake is basically matching till six. Bite Swamp is 12, yes. So now which one? Danger River and Bite Swamp. Yep. Danger River and Bite Swamp. Bite Swamp. There we go. Perfect. Now, what are they doing to ask us? Dina measured the height of her favorite snow sledding hills and graph the results. So she's just measuring basically the height of her favorite snow day sledding hills and graph the results. Yes. Now what we're trying to determine here is the height of our favorite snow day sledding hills. So now snow day sledding hills, okay. So sledding hill, this is basically describing blizzard run, winter hill, snow slope. What is a sledding hill? Let me just see. Yeah. It's just basically describing, those snow-covered areas. Basically, that is used for recreational sliding and coasting stuff. So like which areas? Blizzard Run, the Snow Slope, Winter Hill, and Frozen Field. These are her four favorite Sterling Hilton, just describing what is the height of height in meters. Height on, I guess, no, I think. Just describing the, oh, I don't think that it's describing the height of the snow. I think it's just describing height of the specific place, maybe. Either way, it's just describing the height of that, I think we can just say. And then, yeah, just trying to describe here, sorry, excuse me. So she's just trying to describe the height of those specific locations, specific sliding hills. And then how many meters shorter is snow slope than blizzard run? So now let's determine the height of each of them. This one is matching till 70, matching till 60. This one is matching till 40. This one is matching till 10. Snow slope. Snow slope means it's just about 40. How many meters shorter is snow slope than blizzard run? Blizzard run is 70, snow slope is 40. What is 70 minus 40? That's basically the question. How much shorter is Blizzard one than, I mean, sorry, how much shorter is Snow Slope, which is 40, than Blizzard one, which is 70? How much shorter is 70? How much shorter is 40 than 70? So what do we do? 70 minus 40, which is just about 30. There we go. Perfect. Okay. Now they're asking us, in which graph does the height difference between Winter Hill and Frozen Field equal the height of Blizzard one? Yes. Now for this one, what do we do basically here is height difference between Winter Hill. So Winter Hill and Frozen Field are two different locations, two different sledding hills. We're going to see the difference between both of them should equal the height of Blizzard one. Now what do we do? So let's take a look at the first graph. Okay, there are how many options? Me two options. Yeah, okay. We don't have much options here, so basically it's kind of easier just to deal around here. So we have to see Winter Hill and Frozen Field. Winter Hill and Frozen Field, what do we see? This is okay, Winter Hill. So Winter Hill is at about between 10 and 20. What number comes there between? 50. Yeah, perfect. And what number comes at Frozen Field? 50, right? Yeah, 50. So now what we do here is, what is the height difference between 50 and 50? 50 minus 50. 35. Now, Blizzard 1. Blizzard 1 is at what height? Over here. We see that's 35, right? Between 30 and 30, 40. That's 35. And 35 equals 35, right? Our difference is also equal to that same thing. So we just choose option number A. Perfect. Okay. Let me resolve this. Do you measure the heights of her favorite snow sledding hills and graph to this? So she's again same thing, measuring this thing. Same thing over here. And which hill is higher than snow slope but lower than blizzard one? What do we see here is which hill is higher than snow slope? Snow slope is at which height? Is 40 meters, right? This is actually between 0 and 20, which is 10. Let's write it down the height so it's easier to keep track of 60 midway. So it's 70 between 60 and 8. Now, how which hill is higher than snow slope? So which hill is greater than 40 but lower than blizzard one, which is 70? So which is between 40 and 70? Indirectly, they're just asking us. Now we just catch here. It's just Winter Hill. That's just 60 between the two. So we say Winter Hill is the between the two one that is higher than snow slope but lower than blizzard one. Awesome. Okay. Davy the dragon. Let's see. I think it's let me just change the color here. It doesn't become an homogeneous color. Okay. Just keeps things fresh now. Davy the Dragon Keeper measured how far each of his dragons can blow fire. So now Davy is measuring how far they can blow fire. Now, if someone can blow till 50 meters, like that, and just still blows till 50 meters, or say 100 meters, something like that. They're just trying to measure here. It's like a big dragon. They're just saying here which can blow farther than the wings. Okay. So wings is blowing at which? Let's first of all determine the height. Let's determine the uh fire following distance. So biograph is also written like this, where you have the dragons here and the numerical values on the y-axis. X-axis is basically dragons. Both ways you could, have basically whichever way you want to have, you can have. So that way is what we can do is we can just determine first of all the fire blowing distance from it in centimeters. In meter, yeah, in centimeters or meters. Either way, but here is the centimeters. It's like a big dragon was meters. Here it's like a smaller one, so it's centimeter. The Sparky is blowing at which height? 150. What is Spike doing at? 270. Okay. Flames doing at 180. Yeah. Now Blaze, right? Yeah, Blaze is doing at 300, right? Yeah, 300. Wings is doing at 210. Perfect. This one was kind of easy, just so all the bars are kind of. Which could be even something like that as well. That ways it was these paragraphs would be kind of rotated 90-degree left, counterclockwise, like this. All the bars would be there, and all the values would be here. All the sparky, flame, blaze wings would be there. It could be like that also in this way also. Two ways we can make a bar graphs. But anyways, to the question here, which one is blowing farther than wings? Now, which one is blowing farther than 210? That's basically that question. Wings is 210, so which one is doing more than 210 centimeters? What do we say? Which one is more than 210? Well, let's check out. 150 first. Is that no? That's smaller than 210. How it comes out. Let's check the other values. 270. Is that greater than 210? Yes. Well, it's good. It's good. 180. That's small. Look, 300. That's actually greater. Yes. So yeah, this one is actually also for us. We just have two values, and those are Spike and Blaze, right? Yeah, Spike and Blaze. Spike and Blaze. We'll check them out. Spike and Blaze. There we go. Okay. Yeah, the background I was just talking about is just given over here, sketched out here. So yeah, Julia counted the number of students in the classes and graphed the results here. So just graphing the results up here, writing science, math, chorus, number of students in each class, and then now we'll just see how many fewer students are in math class and running class. They're just basically asking. So we just need to count all the students in all the four classes. So kind of get the difference and fill it in there. So running is how much? Running is 32. Science, 16 and 24. Well, that's between 60 and 24. What number comes exactly between? Comes is 20. Yep. What number this is? 24. Okay. What number is this is? No. Yeah, this was about at 32 and if we see that's 36, right? Yeah, 36. Now, chorus is 36, math is 24, science is 20, writing is 32. Now that we know all of this information, we can see how many fewer students are in math class and running class. How much fewer is 24, this value, than a running class? That is 32. 32 minus 24, what is that equal to? That is equal to 8. So what information, what number we put? We just put is 8 students. Okay, awesome. Now we have a bar graph over here again. Now just asking us, shows the pieces sold at Pizza Town on Tuesday night. So Tuesday night, they just sold these pieces at our Pizza Town. Let's say on Tuesday night. So number of pieces sold, let's say, with the topping mushroom, they don't have the information that here, but they have cheese. Cheese is sold at how much? It is sold at 75, right? Yeah, 75. Between 70 and 80. Now, how many pepperoni were sold? It's 55. Yeah. Sausage were 40. Now they're saying is number of mushroom pieces, that's actually question mark. Sold is the same as the difference as between number of cheese pieces and sausage pieces sold. So it's basically the same as the difference between cheese and sausage. What is the difference between 75 oh, and 40? Basically this. What is that difference? 75 minus 40 equals 35. 35 is going to be mushroom. So if you grab that, that's going to about fill here like that. Something like that about here. So yes, we'll say it's about 35. Awesome. Yeah, okay. Well, let's do the next lesson. So now we have this. Okay, I think we just have it there. Okay, reading two-way frequency table. So now this way is basically like, where you have graphed data. Now two-way means what? One-way means like basically if you're just graphing, say, preference for cats and dogs. Well, let's say male and female students in our class. You could just say something like male and then female. That and that's 20, 40. That's it. Small little cool table. We just have it's one way. Two ways means what? You have two ways, okay? The left and right data. So someone, could be here just male and female. That's it. We don't have any other thing. We don't have race. We don't have, their likeness of something specific. We don't have something like, the average income levels or a preference of cats or dogs, preference of any favorite subject, preference of any sports, anything favorites, we're not considering here. Otherwise, we can say this is just one way. Two ways means we're describing two ways the data, okay? So describing two attributes of data. We're describing the preference and the male and female. So yeah, here it could be someone who is preferring dogs and is a male, who is preferring dogs and is a female. Okay, two things we have. And there could be some people who are preferring cats but are not female, or there are some people who are preferring dogs but not male. Something like that you could have here. And then there's no preferences. Only know some people like I don't prefer either animal is fine, or I don't like any animals. That way, so that's no preference category. You just try. Yep. Three ways also exist. Yeah, think three ways do exist, but I think three ways may not seem curious. So yeah, two ways let's just keep for now. So basically, they are saying how many students in the sample were female. Now, how do we consider this out? How do we figure this out now? Female. So how many females were there? Okay, this is female category. This is male category. Regardless of preferences, they're asking. They're not asking us which were females who like dogs. Okay, otherwise we'll just say 20. But they're asking all the females. So 20, 26, and 6. Those are dogs, cats, no preference, only the females. So 20, 26, and 6, we just add all of those three values. We just add those around. So 20 plus 26 plus 6. What is that equal to? That's equal to 52. Yep, 52. So we can say how many students were female? 52. If I said how many female students were male, we'll just see here. 36, 10, and 2. That is about 36 plus 10 plus 2 is how much? 48. Yeah, 48 were male. So then total, how many students were there? 48 plus 52, which is about 100. Yeah, total about 100 students. There we go. I'll just raise the smile. I'll just go to the explanation here. Yeah, to find out how many students when the children in the sample were female, we can add the total number of students in that column. So that means we just add, yeah, in that specific column. And oh, sorry. Yeah, we just add the specific number of students in that specific column. And now here we just have this one. So yeah, we just add all of the female ones here. So yeah, we just add just 20, 26, 6, and yeah, we get 100 students in total. 52 were female, so 48 were male. Okay. Research surveyed recent graduates of two different universities about their income. So yeah, this is about their income, how much they're earning for University A, University B, those specific graduates. The following two-way table displays data for the sample of graduates who responded to the survey. How many graduates in the sample had an income of 40,000 or over? How many had 40,000 and over? So yes, how we'll figure that out is we'll just see this part. We'll focus on this. We have to just add, this way. We're asking how many students are in University A. If that was the question, we would be adding like that. But they're asking us a question is about how many students were doing like this way. How many were 40,000 and over? So it's basically kind of a horizontal thing. We need to add the horizontal way 35 plus 37, which is about 40, not 40, I mean 72, I think. Yeah, 72. 90 plus 63. If you just try to, add all the income levels, we can just kind of figure out how many students in total we had. 90 plus 63, if you see that's about 153. 35 plus 40 is 75. And if you just try to see how many students we had, so 75 plus 72, which is about 147. 147 plus 152, 992, 299. 299 students in all we had. Even if you try the other way, like, adding these students like this way, that also you can arrive at the same number. We'll just try that real quick. So 35 plus 35 is about 70. 70 plus 90 is about 150, right? Yeah, 150. And then to 40 plus 37, that is 77. 77 plus 63. So, right, yeah. Did I make a mistake here? Or... Yeah, I think I'm correct. Oh, yeah, so I think I made a mistake. Yeah, 153 should be, because this one is 300. I see. Sorry, guys, it should be 300. 300. Yep. And then we try to add here 77 because 40 plus 37 is 77. 77 plus 63 is going to be about 100. And if you see like a 3, that 77 plus 3 is 80. 80 plus 60 is 40. Hmm. Wait, am I doing a mistake here? 77 plus 63. 140, right? Yeah, 140. Okay. Okay, I see. I think there is some mistake I made. And yeah, I see. Okay. Yep. 35 plus 35 70, but 70 plus 90 is 160, not 150. Okay. Yeah, 160 plus 140 equals 140. So either way, we're equaling 300 students, in which how many are over 40,000? 40,000 and over? There are 72 students. Those kind of good earning ones, not like the lower middle class ones. They kind of like good earners of income as graduates. Okay. Now let's draw this one out. So this one is this. Researchers once surveyed of students on which superpower they would most likely to have. So this surveying like you would have like to have, invisibility of flying, which superpower you want to have. Two variables is displaying the data for us over here, just responding to the survey. Now, how many males choose to have flying as a superpower? How many males are there? This is the main category, of which how many chose? Now they're asking very specific here. They're asking here two-way, okay? How many males are choosing flying? How many males are not choosing invisibility or the other? They're asking just males for them flying. How many males are choosing flying as a superpower? How many? If you see here, it's going to be 26, right? 26 males are choosing flying as their superpower. They're going to fly one day. There we go. Okay. Researchers one survey to call the students and their Facebook page use. The following two-way survey table displays the data for the sample of students responded to the survey. How many students in the survey responded that they use Facebook? Okay. How many use Facebook? Now, so uses Facebook, does not use. Regardless of their age. We don't care for the age, we just care if they use or not. So we just want to see here is basically what is 70 plus 70? 8. So what is that equal to? 148, right? 148 use. And how many don't use? 70. If you just add 4 plus 67, that could be about 71. Yeah, 71. In total, how many students are there? 209. wait, 220, 219, 219. Okay. Yeah, 219 in total. And then we have 148 who are using Facebook. And then 148 are using Facebook. 71 are not using. There we go. Okay. Let's just see the next exercise, and then maybe we'll just end here. We'll just discuss the next exercise in the next video. So yeah, let me just end the class over here. I'll just end the class here.